Hello, Mr. Fry's Algebra 2. If you were not in class, then you're going to need number 3 and 4. If you couldn't see it because of the board glare, whatever. If you missed it for whatever reason, I have it here for you. We did these in class, and then he asked you to do 5 and 6. I will go over 5 and 6 also. Okay, so key to understanding these is using your graphing calculator or Desmos. I'm using Desmos here so that it just makes it real nice and easy so that you could see all these points that we're going to be needing to identify. So you plug in this equation, and using the keypad down here on Desmos, just, nice, it's real easy to plug in. In order to get that 3 there, you want to hit that a to the power of b. That will give you the 3. You could select 3 as your exponent. And then in order to get back down out of the exponent area, you're just going to click right behind that, and then you're going to put in your plus, just in case you're having any problems keying it in. Okay, once you're there, leave it on there. And I have, it looks a little confusing because I have number 4 up there also, but that's going to be in green. We're looking at in blue with the gray dots. Okay, the gray dots, once you've highlighted the problem that you're working on, the gray dots are going to be points of interest. I have extra points where it intersects that next problem, but we don't need to know those. So those gray dots are going to be points of interest for answering these questions. Okay, so let's get going. What is the relative minimum of this equation? So the relative minimum is going to be this point right down here. Oh, I came off of it, so I have to highlight it, and this point right here. That's the relative minimum. So that's the point 0, -2. That's why I have 0, -2 written there. Okay, you could pause this as I'm just going to keep on going. The relative maximum, how did I get 2.2? What does that mean? Well, the relative maximum is where, during this little, this section of the graph where it does come up. Okay, and that's going to be our relative maximum. So that's going to be 2, 2. The x-intercepts. So you're just going to find where this blue line intersects the x-axis. So there's the first one, and I have that written down. There's the next one, and I have that written down. And there's the next one, where it crosses the x-axis. Okay. Then the y-intercepts. You're going to have one y-intercept, and that's right there. And then at what intervals does the graph increase? Notice it increases from that point to this point is when it's increasing. So you could put that in words, as he said in class today. You could say the graph increases from this point, and label that point, to this point. Or you could write it in greater or less than notation. You could write when x is greater than 0 or less than 2, that's when the graph is increasing. Okay, and what intervals does the graph decrease? Well, when x is less than this, it is decreasing. By that, I mean that it goes this way, okay? It's decreasing. And then it's decreasing again after this point. So when it's greater than 2. Okay. The domain for this is going to be, so the x values is going to be all real numbers. So it keeps going forever and ever, wider and wider this way, and this way, even though it takes a long time, wider and wider forever and ever this way. So all real numbers it's going to cover on the x-axis, okay? And then the range is all real numbers. So you could either write it like this, negative infinity, positive infinity, negative infinity, positive infinity, or you could write it as all real numbers. It means the same thing. So the y values, the range, it keeps going up forever and it keeps going down forever. So that's what that means, all real numbers it covers. So when you have these cubic functions, called cubic functions are with the 3. They're always going to be all real numbers for the domain and range, because they're going to come from all the way up and go all the way down and go all the way that way and all the way that way on the x-axis too. When you get into quartic functions, you know, the 4, then it kind of goes back up, and then so it's going to have a minimum, and you know, it will be y is greater than or y is less than for the range, but the domain would be all real numbers still. Well, going on to number 4. Okay, take a look at this one. You plug this one into Desmos, and I already did, and I'm going to highlight that one. So that one's in my green. And the relative minimum, the first question is relative minimum. So the relative minimum is when it hits right here at that point. That's why that point I have for relative minimum. And the relative maximum, where did I get that? That is right here. Right there, that number right there. You gotta be careful because I got a lot on there. Okay, so that's where that number comes from. The x-intercepts, once again, where it crosses the x-axis, so right there, and right there, and right there. And I kind of rounded those off for the x-intercepts. We did in class. The y-intercept is right here. There's one of them, crosses the y-axis right there. Okay. And what intervals does the graph increase? So x is going to be less than this number. When x is less than this number. What does that mean? Okay, so x is less than, it's going to be increasing when it's less than, I'm sorry, that number right there. Yeah, that 0.06. I got a couple numbers in there that are real close to one another. So when it's less than this, it's coming up, it's increasing, right? And then when x is greater than that x value, 1, when it's greater than 1, when it's greater than 1. So less than this much and more than this much, 1. In what intervals does the graph decrease? That's when it's in between these two. So in other words, this section on the graph right here, from there to there. Okay, so that's why x is in between those amounts. That's when it's coming back down. And then domain and range, all real numbers. Okay, the ones that you had to do on your own, let's take a look at these. I want to show you this as a whole. The relative minimum on this one is, and I'm rounding these, they're by no means perfect because we weren't given an equation to put into Desmos or your graphing calculator, so it looks like it's close to 0, -4. And the relative maximum looks like about 1.52. And then the x-intercepts look like they're here, here, and here, and I have those listed there for you, those points. And the y-intercept, I don't know why this bracket looks so ugly, but it's 0, -4, that's right here, where it crosses the y-axis. And then what intervals does the graph increase? Okay, it increases right here when x is less than the -1.5. I could write it like this too, if that makes sense. So when it's greater than 0, when x is greater than 0, but it's still less than -1.5, that's when it's increasing right here, this section. Okay, that's better than that way. It means the same thing, but it's just backwards. And what intervals does the graph decrease? From here to here, it's decreasing, so it's x is less than 0, and then it's decreasing from here to here when x is greater than 1.5. Domain, range, all real numbers. This one, the relative minimum is right here. That's 1, -5. What is the relative maximum? That would be here. It's about negative 1.5 and 0.5. What are the x-intercepts? About these numbers that I've given you. Looks pretty solid. -2, -1, and 2. What are the y-intercepts? That looks pretty solid. 0, -2. And what intervals does the graph increase? Well, it increases, it's going up when x is less than that, -1.5. So everything beyond back here, it's increasing. And it's going to increase, when x is greater than 1. So it starts here and it starts going back up. So x is greater than 1. In what intervals does the graph decrease? Just from here to here. So when x is in between -1.5 and 1, it is decreasing. Domain and range, all real numbers. Okay, hopefully that helped you get this assignment done, and see you next time.